Set 37 degrees and have a box on an incline. And it says, number one, let's say for some reason you have a box on an incline like the figure below. There's your figure. If this incline is at an angle of 37 degrees and the wooden box has a mass of, so the mass of the wooden box is 27.458 times 10 to the 6 grams. Is the box moving or stationary? And explain why that is your answer. Some helpful information. You have the coefficient of static friction equal to 0.341 and a coefficient of kinetic friction equal to 0.158. I'll show you the first trick.
I will switch your mass.
You're going to change that mass.
Yeah.
It cannot be in grams. It's got to be in kilograms. So I want you to do this really fast. You should be able to do this no problem. So it's 27.458 times 10 to the third kilograms.
Yep.
All right. Now I'm trying to figure out if this box is moving. Am I applying a force? No, there's no force being applied. So if there would be motion, what direction would this motion be?
Down.
Okay, so it would slide down. In that case, what direction is friction? It's always opposite of the direction of motion. It's up. If I want to know if something is moving, what do I have to overcome?
The friction.
What friction?
Static.
Static friction. So do I even care about this kinetic friction coefficient? No, it don't matter. So, force
Justin Hatfield from the office.
of static friction. From here, I have two other things. I have the normal force, which is perpendicular,
And gravity.
and the force of gravity, which points straight down. So I'm trying to figure out if this thing's moving or not. I have got to find and figure out what's going on in this x direction. From there, that'll tell me what's my net force in the x direction. So really what I'm trying to find, net force, x direction. So to find this is summation of all the forces in the x direction. So I need whatever forces are going in that x direction. The force of gravity can be broke up into two component vectors. You have the force of gravity in the y component. You have the force of gravity x component. I want to know the force of gravity x component so that I can figure out if this box is sliding.
Yeah.
All right, so force of gravity. Let's see. I'm gonna get my triangle here.
You want to make another one?
I'll just make a triangle. All right. Where is the angle I'm going to be using?
I put it. You talking about the angle inside the triangle?
Inside the triangle.
Probably the one closest to the order.
That's right. It's always one closest to that origin because that's what's turned. I've turned it 37 degrees. All right, so I got 37 degrees. I got the force of gravity x component and the force of gravity y component.
And then your hypotenuse is
Force of gravity.
negative. Right.
Yep. So it's force of gravity. Force of gravity is equal to what?
Negative or 9.81.
Mass times gravity, which is 27.458 times 10 to the third kilograms times gravity is negative 9.81 meters per second squared, and this will be equal to
Caleb Cook, come to the office.
and this will be equal to negative 26,900. 262.98 newtons. So I got this value here.
Now we can find, do we only have to find the force, gravity sub X?
You're going to have to find them both. And this is why you're going to have to find both of them. Is you have the force of gravity sub X to figure out if it'll overcome this friction force. But what do you need to find the friction force? You got to have the normal force. So that normal force is equal in magnitude, opposite in direction, the force of gravity in the y component. So starting us off,
Sine.
we'll do sine, that's fine. So we have the sine of 37 degrees is equal to force of gravity in x direction divided by, oh gosh, 362.98 newtons. So the force of gravity in x direction is equal to negative 2,609,362.98 newtons times the sine of 37 degrees. Which is equal to negative 162,106.688 newtons. All right, I'll need that. See if it's sliding. Then I also need the force of gravity in the y component, so that means I'm going to have to do the cosine of 37 degrees is equal to the force of gravity y component divided by that same number, negative 269,362.98 newtons, which is just the force of gravity. So we'll find the force of gravity y component is equal to the negative 269,362.98 newtons times the cosine of 37 degrees. So,
Mr. Hall,
yeah,
I think, is that a 7 beside that 6?
where?
On your 3-6 up there?
That's a 2.
Okay,
It's supposed to be a 2?
yeah.
Okay. Sorry, bad handwriting. Oh. Times cosine of 37 degrees, which will be equal to negative 2,215,122.8409 newtons. The important part of that information is I need the normal force from it. So the normal force is equal in magnitude, opposite direction, the force of gravity. So normal force is equal to the opposite of the force, the gravity y component. Sorry.
Jessica Orlesky from the office.
So it is equal to 215,122.8409 newtons. And I'm going to use that to find the force of friction. So, force of static friction is less than or equal to the static static friction coefficient, which was given to you to be 0.341 times normal force, which is 200, 15,122.8409 newtons. And you'll find that to be less than or equal to. Should get 73,356.8888 newtons. All right, then you got to find, like what I was telling you before, we have got to find the net force in the x direction. So what all's happening in the x direction? Here in the x direction? Go ahead.
Your force, your G sub X, and then your, what we just found.
Yep. Force of G sub X and the force of static friction. So we're going to get a summation of those. This is the thing. This is in the positive direction. So net force of the x direction is equal to, I'm going to do 73,356.8888 newtons plus the force of gravity x direction. What did I do with it? Force of gravity x direction is plus negative 106.688 newtons. You're going to add those together. So we're going to do 73,356.8888 minus 162.106.688. Which will be equal to negative 88,749.7992 newtons. Now that's not the answer. That gives you the information you need to find the answer. The question asks you, is the box moving or stationary? And explain why that is your answer. Is the box moving? The box is absolutely moving. Why? Because the net force in the x direction is coming down the ramp. So it's pointing back. There's a force applied to it, a net force being applied of negative 88,749.7992 newtons.
Could you say yes because the net force in the x direction is greater than that by that much? Could we use it?
Yeah, I'm cool with that. I would want to see, as long as you showed me the math. If you're just going to, because if you're sitting on your quiz and you just pull it up and you're like, yeah, because this is greater than this. It's one of two things.
If you put the numbers in.
Yeah, even if like Matt, even if you had this math showed here, and then you said yes because the force of gravity in the x direction is greater than the static friction force, I would take that. I'd give you full credit because you showed me the math, so it shows me where you got your numbers at. Do you have any questions?
If it's positive, is it moving?
In this case, no, because if it was positive, then it'd be like all the force is being pushed that way.
But the box-
Well, yes, it would be moving because all of it would be going this way. But it's not going to happen. In this case where there's no force being applied to it, no. The only way this would flip is like we did that one problem where we applied force. So if I was pushing on this box, what way would the motion be? The motion would then be up the ramp, so static friction is down the ramp. So you're looking to see if it's gonna move up there. Does that make sense, or is that
Yeah.
confusing?
That makes sense.
Okay.